All right, so we're going to make our third and hopefully final video notes here. We're talking about even radicals. This is just kind of continuing that same idea. If we're looking at even radicals, if we are taking the xth root of a variable to the xth power. So when these are the same, if x is even, then the answer is going to be the absolute value of a. Okay, when it's odd, we don't have to worry about that. Odd values, so if we're looking at maybe the third root of x to the third, well, we don't have to do the absolute value for that because a negative times a negative will give us a negative. So if x was -3 in this case, -3 times -3 times -3 would be -27. And we saw earlier that the cube root of -27 would be -3. But if we were looking at maybe a positive value, like the cube root of 27, well, that's going to be 3 times 3 times 3. So that would just be 3. So for odd radicals, we don't use the absolute value symbol. For even radicals, again, if the root is the same as the power, we need to remember to use the absolute value. And so in this first one here, we've got 4 and 4. Those are the same. Those are even. So we're going to have the absolute value of 2a. In this case, the root and the power are the same. So we do not have to use the absolute value because 3 is odd. So this one is just going to be 5a. So part of this is easy in the sense that when we have the same number, we basically just get to remove that radical symbol. But the thing we do have to be careful about is that idea of the even and the odd and that difference. The even numbers, we have to consider the absolute values. And again, that goes back to what we were talking about in the prior video. Really, one of the last things to think about here is domain. Just like with square roots, which we saw in our last chapter, we are not putting negatives under the even roots. So even roots or radicals can't have negative inputs. So we would have to say that x plus 10 has to be greater than or equal to 0 to keep it from being negative. So we could subtract 10 from both sides. We would have x has to be greater than or equal to -10. And as long as x is greater than or equal to -10, the value underneath the fourth root there will be 0 or positive, which means we can take the fourth root of it. If we're talking about odd roots, say, for example, if it was the third root of x plus 10, well, in this case, we can take the third root of a negative. So we don't have that same restriction that the x plus 10 has to be greater than 0. So the domain in this case would be all real numbers. And that's basically what you need to know to complete the final problems in my Math Lab 9 through 14. I know there can definitely be some questions about this, and I'd be glad to respond to your emails or set up a conference to talk through some of these problems as we're going through this extended e-learning. I know this is extremely different learning experience for you, and we want to make you as successful as possible during this time. Just a quick note, there is a strange problem, number 12. When you're looking at number 12, it's going to say something, assume that the radicand was not formed by raising a negative number to an even power. It's basically a fancy way of explaining that you don't need to consider the absolute value in that case. If we're saying something like the fourth root of x to the fourth, they're saying that we're not putting a negative value in for x, so you don't have to use